Just last year, my research group here in Padua discovered that within an African diamond there was a very small mineral with a composition calcium silicon oxygen, what we call calcium silicate. And this calcium silicate had the same structure of what we call perovskite. Perovskite is a mineral common in nature with the composition calcium titanium oxygen, and actually its crystal structure is very famous, especially in industry, because it has a very important technological applications. So let's go back to our discovery of last year that we published in Nature. What we found for this mineral is that the composition that we measure on this material had also some small amount of titanium, and from this composition, calcium, silicon, titanium and oxygen, we predicted that this mineral could be formed at 800 kilometers depth in what we call the lower mantle of Earth. I will show you exactly this. This is the Earth's surface. Then we have at 410 kilometers depth starts the transition zone. Then at 660 kilometers depth start the lower mantle. Oops, sorry, here I forgot the upper mantle. So the composition of our mineral was predicted at about 800 kilometers. So the calcium silicate we found in diamond probably formed at 800 kilometer depth. But the most important thing that we assumed is that this material, the original material that formed this material, was from the very upper part of the Earth, and exactly from a basalt. What is a basalt? This is a real basalt. You see, it's a rock. It's a volcanic effusive rock, and you see it's almost black. It's composed mainly by plagioclase and pyroxene. And you can see also some olivine. So these are silicates, very important for Earth. And what we actually proposed is that this material, and usually basalt is formed here on the surface when you when you get cooler the basaltic magma. And what we propose is that this material in some way reached this 800 kilometers depth. How? The only process that we know in geology is for sure the subduction. So we propose that the tectonic plate goes very deep by subduction process. Okay, so why today I'm talking about this discovery of last year? Because some colleagues from Jaime and Tokyo University published in Nature a very recent discovery just in January. And they did a very special experiment. They took exactly the same composition of what we discovered in the diamond, the calcium silicate perovskite, and measured the wave velocity with the seismic wave velocities inside this material, but when the material is still kept at about 700 kilometers. So they took the material, they kept the material 700 kilometers and measured, and 1700 Kelvin, and measured the wave velocity. They discovered that the wave velocity of this material at that depth is about 26% lower than what we expect for the material at this depth. And from this discovery, they proposed that they actually confirmed that it is possible that the basaltic composition can be exactly can arrive to this lower mantle shell of our planet, and therefore the idea that in these last years is coming out from our discoveries is that there is a very important recycle of basaltic materials from the oceanic crust on the Earth's surface down to the lower mantle and probably back when we found diamonds. So this is a scenario that was absolutely unexpected until 5-10 years ago.